All right. So once again, to understand this statement, so concave up means that f prime of x is increasing on the interval. Tell me, on both graphs here and there, what can you say about the slopes? Are they negative or positive? Negative or positive? Here, Rami, is it negative or positive?
From this one?
Negative.
This is negative.
If you look from this way, it's negative.
There is only one way.
From left,
only one way. So it's negative slope. What about this one? Positive. The conclusion is, if the function is concave up, does this mean that the slope has to be negative or positive? There is no link like this. But the slope has to be increasing. Okay? So now it's easy to understand when the slope is positive. Like, for example, Mohammed, here and here. Which one, the first or the second one is steeper? The second one is steeper. It means that if it's steeper, and we're talking about positive values, it means that this value, for example, 10, right? And then this value should be what, approximately? 5, for example, or 2, right? So the value, you remember the slope is one number, right? It's a value. So on the positive slopes, it's very easy to understand that, of course, when it's concave up and the slope is positive, it's increasing. On the negative part of the slope, it's not decreasing, it's still increasing. This is where the twist is.
Why is it not decreasing?
Oh, this is what we're going to discuss right now. So tell me, Omar, which one is more negative, this one or this one?
The one on the top.
So the one at the top is more negative. Steeper. For example, negative 10 and negative 2, okay? So now tell me, if you just detach from the slopes and think about the two values, negative 10 and negative 2, which one is greater? Negative 2. If you forgot, always go back to number line and you know that whatever is to the right is greater, right? So that means that really the slope is increasing. The slope here is increasing because it's becoming flatter, which means less negative, okay? So, but conclusion, again, concave up means that the slopes are increasing. Concave down means the slopes are decreasing. Do we need to discuss it here? For example, here, how can you explain on this part that the slope is indeed increasing here, decreasing, sorry. It's not here, how can you explain that this is really decreasing here? The slope is decreasing. I want you to explain.
So like the second one is steeper?
The second one is steeper. At the same time, the slope is negative or positive?
Both of them are negative.
Both of them are negative. So if this is steeper, means it's more negative. More negative means less, right? More negative means less as a value. Okay, so this is the main idea, which the second derivative test is based on. Okay, so.
So we're going to see just from the slopes if it's concave up or down then?
Yes, but since we don't know how it looks, we are going to analyze the slopes. Okay. Like, how do I know if the slopes are increasing or decreasing? It means that I have to determine if the function, the derivative function is increasing or decreasing. And this is, I know how to do it, okay? You will see right now. So I'll now take an example so that it's clear on the example, and then we'll touch upon some theoretical aspects again, okay? That was an example on page 200, okay? Okay. Okay, so we have a function. What is the type of the function, Abdurrahman? Type of the function?
What's after
Noor, type of the function, cubic function, but more general type of the function, polynomial function. Now, in order to analyze, to sketch it and to analyze the concavity, we are going to use the first and the second derivative, okay? So, At this point, I would like to ask you, you already did an assignment where you used the first derivative test, which helps you to sketch. So tell me, what is the main purpose of using the first derivative test? What kind of useful information does it give us? Omar. It's a very vague, again, answer. I don't know what to do with this. Elaborate. How does it give us tangent? And what do you do with the tangent and the curve?
Tangent at a specific point, if you substitute the x.
Did you do the assignment?
Yes.
Okay, so how does the first derivative test help you to sketch?
I can't remember.
Noor?
It tells us the maximum and minimum.
Gives us the maximum and minimum. Because they are very important points on the curve, right?
Yes.
Maximum and minimum. So the first derivative is always giving us the maximum and minimum. The second derivative is going to give us a different type of information, different characteristic about the function, okay? So if you do not know, then to find the derivative, the second derivative, I first need to find the first derivative, right? And then based on this, I am looking for the second derivative. So this is the second derivative, no surprise that it's linear, right? Because every time I differentiate, I decrease the degree by 1. Okay, now what am I going to do? Before I explain this part, so that it's clear, I want you to go through another exercise. So remember this question where we were given a function, okay, and just a curve, okay, and then you were asked to sketch the derivative function on top of it. Remember this question? Okay. This is where it becomes very useful. Okay. So let's do it. You know what? Since you all forgot, let's do it as a warm-up. So you can copy this in your notebook. Who remembers? I want you to do it on the board. Who remembers this? So you need to sketch f prime of x on top of this. I'll tell you why am I doing it right now. Because based on this, you will understand how the second derivative and the first derivative are linked. You know how to do it?
Yes.
Can you do it on the board? Yes. Okay. Guys, everybody else is doing this as a warm-up in their notebooks. It doesn't have to be precise, just repeat the shape a little bit. It's an even function with a negative leading coefficient. You need to sketch f prime of x. Yeah, you can do it on the board. So Noor and Habib over there, and then we'll compare. So please use different colors so that we understand.
Can I do it on the board?
No.
Right.
You will do the next thing on the board, okay? So different colors, and just do it. Guys online, of course, this is the warm-up for you as well. It will, really, you will see, it will help you to understand the algorithm rather than to memorize it. You do it?
No, I don't have it.
You don't remember? That was in the quiz which you were doing the second time. And I think this question you didn't know, right?
No, on the first quiz. It's supposed to be
it was
like the last page.
Yeah, something like that.
Isn't it supposed to be the gradient of the first function and the placement of the graph is positive, negative?
If the slope is positive, the derivative is above x-axis. Mm-hmm. Omar, can you sketch it and show me in your notebook?
Sketch this.
And then derivative on top of it. Guys online, who was able to sketch it? Send me the picture by email. The thing is, and I told you guys, this is going to be part of your assignment. You cannot avoid it. So the sooner you understand, the better. Guys online, if you are ready, tell me so that I know you will send me the email, okay?
Okay.
Which one is the derivative?
The purple.
اه ايه ده ايوه
The purple one?
غلط ايه اللي صح؟ انا عارفه إني صح.
انا حاسس ان
أنا صح.
Here, what can you say about this one? Negative. Where should the success rest?
بس it's either like this
We're not guessing. We're not guessing. It's a very precise here.
it has to be the other way around.
Because it's negative first.
This is correct. This is correct.
This is like this?
But until
يعني
this is until here it's decreasing. So
Yes.
let's switch.
Then
This should be the other way around.
Not the other way around. So this is correct. Then this is the zero. This is correct. Now it's decreasing until here, right? So that means that it has to be until here. And then it's increasing, so it's increasing until here. So another zero. It's like this.
Okay, thank you.
Can you do it again with the lower? If you don't know, I don't know either. What's happening between this point and this point? No, between this and this. What's happening between this and this? It's decreasing.
But how is that system? It goes back up?
Yes. Nobody forced you to work with them. Just you always, and then after
Oh,
you
we
release
do it
it
like
back. This is wrong as well.
ايه ده مش عايزين كده
And this is wrong as well.
ايوه الجماعه على دي
Oh, yeah, it's totally
Totally here. So like there is something there, but I don't know. Look, this is when it's created.
something like this and this
After it's so negative until here, and then it's increasing, so it's above. Okay, so
This is that, right? Hey, that's how we did it.
guys, enough. I will sketch on the board and you will check, okay? So let me once again analyze this part. I don't know. It's still not. Okay, guys, let's go over it last time together. So what I was telling you, that you have to break down the number line into the intervals. How? By determining the zeros. How many zeros of the derivative do you see on the sketch? Right? So 1, 2, 3. This is like your milestones, okay? So 1, this is where the derivative has to intersect the x-axis. So it's not something like approximation. What you're sketching is approximation, you know? No, it's not. So it has to be exactly cutting the x-axis at the zeros, okay? So this is the zeros of the derivative. And then you start analyzing. So Noor, before the first zero, is the derivative going to be below x-axis or above? Above, because the slope is? It's not increasing, it's positive. It's also decreasing, the slope. Because here, do you see that it's more steep? And here it's flat. Do you guys see the difference between increasing slope and positive slope?
yes
Okay, the slope is decreasing but positive here. If the slope is positive, it means the derivative function is above x-axis.
If it's decreasing, it means it's going down.
No, we are not analyzing if the slope is decreasing or increasing. We are only analyzing if the slopes are negative or positive. Maybe if you remove the music from your ears, it might help. It might not, but chances are bigger. So after the first zero until the second zero, Omar, describe the behavior of the function. Is the function, I mean, in terms of slope, is the slope negative or positive? From this until here, negative. If the slope is negative, where is the derivative function is? Where the derivative function is?
so it go down
Down is very relative. Below x-axis, above x-axis. Below. So from the first zero until the second zero, it's like this, right? Now let's analyze the third interval. The next interval, I don't know, third or which one. Right? From here until here, how can you describe the slope? Slope, forget about increasing. Slope is positive, means the derivative is above x-axis. We need locations. We don't need other details, right? And then afterwards and until the infinity, what's happening to the slope? Slope is negative, so it means the derivative function is
That's what I do.
the derivative function is negative. It means that the derivative function is negative. Okay.
That's how we did it.
If you look, that's what I do. Just to hear. Exactly.
Exactly. Okay.
That's how we
It's
did it.
not exactly.
No, I think that's the zero. Sorry.
So it's not exactly. So go and change it.
Miss ours
If it's 1, 0 is wrong, then
Miss ours is correct.
Yes, I think.
yes. After I have corrected it 3 times. Yes, it's
Yes,
correct. Yes, you corrected it. Well. Okay, guys. So you should have got something like
Can we
this.
do it again?
Now I will tell you what we're going to do. It will be kind of the same process, but if now this is the blue one, so I'll repeat it here. The blue one
The second derivative?
is the first derivative still. But yes, let's sketch something like that, okay? So if this is the first derivative, let's sketch the second derivative.
Using the first derivative.
Yeah.
Exactly. So
Sketch it on the board.
just a second. So think about it. What is the second derivative for the first derivative?
The same.
Is the derivative.
Yes.
So the relationship between the function and the first derivative is the same as the relationship between the first derivative and the second derivative, right? So you need to analyze the same way and sketch the second derivative on top of it. And then we will use this in the algorithm, okay? So you guys do this work on the board, in the note, wherever you stopped.
In seconds.
Hey, that's the
No, the three, okay, you repeated this. Are you sure that it looks like this one?
Huh? No, do this one, but you do it.
No, you have to work with yours.
Really?
Yes, because so that you see that it's the same thing. Yes, you also you guys work on top of the same coordinate plane. I put it aside to make it clear, but generally,
This I just redo it.
if you think that you want to use, you might be confused by too many gas. Copy it. If anyone online wants me to see their graphs again, send me the picture. I don't see that you sent it to me. You finished?
Sorry.
Here it's decreasing, here it's decreasing.
So the right? Also we
It's not this decreasing.
Was you
Yeah, it's below.
Yeah.
Is this the like this?
It's increasing, that's increasing and
You're right, because here it's increasing.
the problem? The problem?
And then yes. Right.
This is like a downward, I don't know.
It looks like a downward spiral, right?
Yes.
This is very good. I did it on my graph.
No, it's not like this. It's not like this. Look,
Maybe kind of similar.
it's also here. And I'm myself, like, where's the, where's the second? This one is the first, and then do you understand? And then what? It's going like this? Okay. Now, look, do you see that? Going like this, right? This is the first zero. Okay, guys, so let's see. What you were supposed to get is upside down parabola, right? If generally, but it's not enough. If you just got the curve, it's not enough, because what matters on this type of that the zeros are precise, right?
You have to like just show the dots from like this.
So we know that how many zeros for the derivative we have here for the second derivative. So we have two zeros.
You have to show the points there.
We have to show that those are the zeros, right?
Okay.
And then we see that before the first zero, is the slope negative or positive?
Negative.
Negative. It means that the second derivative is below x-axis, right? From the first zero until the second, from the first minimum, from the minimum until maximum, the function is doing what? Which means the slope is positive, means it's above, right? And then after that, it's a negative. After that, it's a negative slope, okay? Was there a question, guys? Omar, did you understand? Yes. So a lot of students, I don't know why, they tend to intersect the function and its derivative here. Because they think, I mean, I don't know, it's
I thought we were supposed to
like if this is the zero of the function, then this is the zero of the derivative. Of course not. So the zero of the derivative is the maximums and minimums. Okay, guys, now, how all of this is related to our today's topic. This is important. So, now, just a second. So we want to think about, for example. So you remember that our original function will think this way. So we have original function, and this is our focus, right? Because we are analyzing the function, which is at the beginning. Then we switch to thinking about derivative, first derivative, and then to second derivative. So we have to take all of them into consideration when we are thinking first about critical points, which is straightforward, second about concavity, which is less straightforward. So let me do the following. For example, let's take a point here, point A. Okay. So this point, let it be on the interval. If you look at the part of the curve, at this region of the curve, only this region, tell me, is the function concave up or concave down from the way you see it?
Concave down.
It's concave down, okay? Okay, so at point A, the f of x is, I'll use the same colors, sorry. F of x is concave down. Okay, now, what can you see about the slope, the derivative function? You remember that the function here is concave down. So is the derivative function increasing or decreasing?
Decreasing.
It's what? Decreasing. If you have a doubt, again, slopes from very steep positive slopes, getting flat, and then get negative. So here, in this region, f prime of x is decreasing, right? Everybody saw this.
Yeah.
Decreasing. Okay. Now, the derivative function here is decreasing. So let's find this point. Will I be able to find it here? Because I want you to find the sign of the second derivative. It's not precise.
It's also decreasing.
Just a second. It's not precise here. So the derivative function here is decreasing. And okay, this is this part, right? It's decreasing. So we already after the max, you see the maximum, we passed already the maximum for the derivative.
Yeah.
It's going, here, it's the function is decreasing, okay? The function is decreasing. What does it mean for the second derivative? Is it negative or positive?
Negative.
It's negative. It's because it's not precise, so it's this part. whenever it's this part. So point A is somewhere here. Okay, it's after the maximum. You see, the derivative function is decreasing. That means in this region, the second derivative is negative. Okay, therefore.
So if one is positive, the other one's negative, and the other way around also?
Is.
So if the other one's negative, the other needs to be
Negative.
positive.
So if it's decreasing, the other one has to automatically be negative.
Let's. Okay, one by one. What did you say?
I said if the first one is negative,
What is the first one?
the normal function.
If the function is negative, it doesn't say anything. We need only to analyze concavity. Concavity. Let's do it again. For example, let's take the function, another point B on the original function here, for example, right? Here. So you analyze the shape. You analyze if the original function is positive or negative. It's not our interest. So at B, tell me, is f of x concave up or concave down?
X?
Here.
Concave up.
Concave up. Does everyone see it? Concave up.
Yes. I don't understand what was
Just a second.
So it's
Hold on.
increasing.
I'm doing this second time. Now, here, the function is concave up. What can you say about the derivative function in the same region? What is it doing? Is it decreasing or
It's
increasing?
increasing.
It's increasing. So therefore, as we can see, f prime of x is increasing. Do you see it, Abdurrahman?
Yes.
In this region, it's increasing. Now, if the function, the derivative function here is increasing, it has a positive slope. What sign will the second derivative have? Is it going to be positive or negative if the slope of the first derivative is positive? It's going to be positive, because if the slope is positive, when you were sketching this part here, so I mean it's after the zero, so it was this part. So the point B is somewhere here. Okay? You don't.
Last part I'm confused. You understand.
So if the slope of the derivative function is positive, then the second derivative will be above x-axis, right? It will be positive.
I'm confused as to where we're looking. Like, Miss Natalia?
Just a second. And okay.
This is an egg, and every class will take one. It's an Easter egg competition for Easter. Every class can decorate it the way they like. This is due on the 13th. So you guys still have some time, and the winner will be getting a prize.
What is the prize? Just a second. We're supposed to decorate this egg?
Yeah, the way you like.
Okay.
فخليها كويسه because the entire school is going to be completing elementary middle school وhigh school. فانت لازم يكون عندك حاجه يعني كويسه.
What is the prize? What is the prize?
المفروض like I think it's a gift card. I
I
don't
see
know.
it's not yesterday.
Okay, guys, what's the deadline? What's the deadline for this? Where? 13th? Okay, thank you.
يا بس no tests بقى بصراحة.
I think that we should replace our test with this egg decoration. Okay. Okay, guys, so yeah, so the bottom line of all of this theoretically now is that the second derivative is helping you to using the second derivative helps you to understand concavity, right? So as you can see, if the second derivative is positive, because you can go backwards, right? In this thinking, you can go both ways. So if you go backwards, then you can say, okay, if the second derivative is positive, it means that the first derivative is increasing. It means that the function is concave up, because this analysis is possible from left to right because we have a curve, but we don't have a curve. We go from right to left. So positive derivative, function concave up. Negative derivative, initial function concave down.
This will we ever have to analyze it the other way around.
Yeah, we're probably going to get.
So we are always going to go from right to left. always. Okay, because we are analyzing algebraically and then sketching it, right? Okay, but this thing was also part of your assignment. Guys, I suggest the following. Let's take 5 minutes break. You will start writing, you will start working on it. And then we'll take questions from the textbook related to the second derivative, okay? So 5 minutes, so we'll start at 10:36.
I love breaks when I do tests.
Really?
That's so good.